Chapter 17 in the book discusses children and sports. And we want to consider whether or not children are just little small adults. And what are our suggestions, or what are our strength and conditioning guidelines for children, really? And how does the fact that children are much smaller and their hearts are much smaller than their adult predecessors, how does that factor into our um, frequency, intensity, timing, duration, mode? How do we appropriately establish exercise as a prescription, but not really a prescription? It's more of a lifestyle choice for children. So the chapter starts with some definitions. The definition of growth, development, maturation. We'll get that. And then what are the acute responses to exercise, and what are the chronic adaptations to training? And then let's give some suggestions on what kind of strength and conditioning exercises we can have this population do. In regards to your chapter definitions, there's three words that sort of seem similar but are a bit different. So the word growth refers to an increase in body or body part size. So I could have something grow without going through maturational changes. So growth is, I could have one cell that grows and gets bigger. I could have a femur that gets larger and more dense. That would be growth. Now, I could have developmental changes, or changes in development, which are functional changes. So I could have one cell that breaks into two cells. Or I could have my collarbone, which changes from cartilage to real bone. Or I could have the fact that I have functional changes in my neurological system as I get older. Allows a child to understand rules of engagement and to have more of a cognitive awareness, or has more um, um, psychological development changes. So not necessarily, these developmental changes don't necessarily have to do with puberty. So you have growth where something gets bigger. You have development where the functional aspects of that particular system change. And you could also have maturation, and maturation has to do with sexual characteristics and being able to sexually reproduce because of changes in hormones. So those would be the differences in those particular definitions. Typically, as an infant grows from 0 years old to its first year of life, that is defined as its infancy, the first year of life. And childhood is the next phase of life from the first birthday to puberty. And then during puberty is when the secondary sex characteristics develop. And then after puberty, until my body stops growing, is adolescence. Usually this is 0 to 1. This is going to be different in males versus females. Females are going to start puberty a little bit younger, at about 10 years of age, maybe even 11, 12 years of age, and males are going to start at about 12 to 13. And then for the most part, our growth cycle stops at about 18 for the ladies and 22 for males. So during these particular years, how does things like height and weight change? Well, from birth to the very first 2 years of age, the change in rate is very high in regards to height. Then it starts to slow down a little bit until puberty. And then when puberty hits and there's an influx of hormones in the system, then the rate of growth increases again. So you take a look at this graph here, and this is the rate of change, the rate of change, the velocity of change. And while a baby is born in the first year, you'll see this is the highest that this particular graph is. All right, if I trace the blue or the red graph, it doesn't matter males or females. You'll see this is the highest point in the graph, and this refers to rate. So right here at the very first year of development is the highest rate of growth. And you'll notice that the rate decreases and decreases and decreases again. Here, the rate is relatively stable. So between the ages of, say, for instance, for girls, 4 and 8 years old, there's pretty steady, you know, slow increase in the rate of change of height. But then at the onset of puberty, there's a big peak in growth, right? Such that the highest rate of growth for females is at about 12 years old. And then it slowly declines until at about 18 years old, there's not an appreciable change in height for females. Similarly, the rate of change decreases until after infancy. During childhood, it remains relatively stable until at about 12 years old, boys start to go through puberty. And at 14 years old, the rate of change or the velocity and the change of their height is highest at 14 and similarly drops down during their adolescence until the rate of growth development is relatively low after 18 years of age. Now, what are the things that make bone grow? Because your bone certainly grows and develops. What are the things that make bone grow? Well, it could be just straight up DNA. It could be that we have like an instructional design, and what happens is that the bones grow that way just because of this mapping. But we could also think about Wolff's law. And remember, we talked that Wolff's law of functional adaptation says that any bone that's under increased force and pressure is going to start to grow in size and density. So it's the forces on bone that start to allow bone to grow. And now you have, for instance, we'll just take a look at, I don't know, you take a look at the knee, right? You take a look at the end of the femur here and your tibial plateau, and you have a couple of different bony landmarks here. You have your tibial tuberosity here. You have these epiphyses here, sorry, diaphyses, which is the end of the bones, and then attached to these big protrusions at the end of your bones, you have ligaments, and ligaments are going to attach like this. You also have a kneecap that's right here, and that kneecap is attached via a patella tendon to your tibial tuberosity here, which is like an outgrowth in bone at the front anterior portion of your tibia. So, where do these shapes of your bones come from? Well, you could think it's straight DNA. And if that's the case, then everybody would have the same kind of general bone structure. But you could also think it's the forces on the bones that are making the bones grow this shape. Now, this ligament attaches from one bone to the next. And say if I pivot or if I turn or if I rotate in this direction, what's going to happen is that's going to cause some type of tension on this ligament. And that tension is going to cause this side of the ligament to pull on that side of the ligament, which is going to create a force right about there. And that force is going to make it so that the bone has to grow to deal with that particular force. So it could be the case that everything is just DNA, or it could be the case that if bone grows because of the forces on it, it could be that the forces on bone are the things that actually make bone grow that way. So imagine in the fetus there was absolutely no movement of the baby whatsoever. And in fact, when there's a baby bump, a lot of times what we do is we go over and touch the baby bump, or when the baby is kicking or moving around, that's something that is kind of intriguing to us or attractive to us. And you go and touch the baby and the belly. It could be the case that that movement in the fetus is more important than we potentially thought. It could be the case that the movement in the fetus is creating forces on that newly developed fetus. And it could be the case that those forces on the bones in the fetus are the actual forces that are needed to expose those bones to those forces. And it could be that the movement within the fetus itself is the very forces needed for the bone to form. So it could be the case that this bone ossification and bone growth has a lot to do with the growth of the fetus within the womb. Now, what are the chances that everybody's womb is the right size? Or that the positioning of the fetus within the womb for everybody is exactly the same? Or what is the potential that if you have twins who are sharing the same cramped womb, what are the chances that those forces or the forces that that moving infant is able to incur within the womb is enough, or the appropriate forces on those bones to establish the appropriate shapes? So if the DNA is, getting you so far, and then the movement within the fetus itself is getting you the rest of the way, what are the chances that everybody's experience within the womb is perfect? And where do things like um, genuvarum, genuvalgus, um, or bow-legged, or changes in the teeny structures of the bone, or differences from one person to another come from? Well, it could be the in utero environment or positioning, or the forces incurred during utero that allow for this bone ossification or a lot of this bone development to occur within the fetus. Then, as the baby grows outside of the fetus during um, childhood and adolescent, all right, there are these things called growth plates. And right, so you have, I'm going to erase this picture, clear all drawings. You have a bone, and the bone looks like this. It doesn't exactly look like this, but this is good enough. And then you have your other bone here. Now, these bones are obviously going to grow, and at the end of the bones, right about here, there's like a little layer. There's a little zone here. This is called your growth plate. And inside this little growth plate is where the bone ossification is going to occur. And then the growth of the bone is going to be out in this direction here. So in this little area of the bone is where more bone ossification is happening, and the length of the bone increases due to bone remodeling and ossification in this area here. Now, there's going to be a growth plate on this side of the bone and a growth plate on the other side of the bone. There'll be a growth plate on this side of this bone. And as your body gets older and older and older, these growth plates close, and the bone will stop elongating. Now, this growth plate here seems to close with adolescence. All right. And for the ladies, it seems as though that there are different hormones that stimulate that closure. And for the most part, The growth plate closing or that bone growth is going to stop at about 20 years. Now, that's not talking about necessarily bone growth in terms of density. It's talking about growth in terms of length. So for the most part, the length of our bones will stop growing or changing at about 20 years old because these growth plates have now calcified and are no longer elongating the long bones. With plenty of calcium in the body, what happens is the calcium will get absorbed from the bloodstream and stored within the matrix of the bone. If there's not enough calcium in the bloodstream, then what will happen is the calcium will be taken from the bone so that it can be used for the processes in the body that need calcium. Like remember, the number one process is just muscle contraction. Now, what calcium does is it helps increase the density, the stiffness component, really, the stiffness component of bone. And remember, if my bones are not stiff, then they become brittle. And a brittle material, so this is what bone looks like in terms of its stress strain curve. So remember, this part here represents the stiffness. It's also the elastic region. The slope of the line here, the slope of the line past the yield point also refers to the stiffness component. Remember, this is the yield point. This is the elastic region. After the yield point is the plastic region. This is where the material is not ruptured, but it's definitely compromised so that the material is less stiff. But for bone, there's still this plastic region. So if my bone does break down somewhat, it's not ruptured or shattered. And then eventually I have my rupture point here. But a bone that is osteoporotic is more brittle. So it means that probably the bone is not as stiff. So it'll be a little bit less steep here in the elastic region. And there's very little plastic region. So if the bone is compromised because of too much stress on the bone, then the bone will strain too much. And because it's brittle and it doesn't have a plastic region, if I do put too much stress on the bone from like a fall or from whatever it is, the bone could shatter. So calcium is essential, but in order for calcium to actually be absorbed by the body, there needs to be vitamin D. So my athletes are indoors. They don't work out outside. So soccer players who work out outside may have a greater exposure to the sun over the course of the summer, and they may have relatively high vitamin D values because they're out in the sun. And if that's the case, they may be able to absorb more calcium. And if that's the case, their bone mineral density values may be higher than somebody who does gymnastics. Okay. So what I do want to show you very quickly is, let's see if I can open up the data that I collect and just show you a little bit about our mid-season strength and conditioning testing. And I'll just show you where our values are. So let's clear all these drawings. So these are some of the value points that I collect every Wednesday. So today is Wednesday. All right. So I collect this data again. So you'll notice that every Wednesday, since I don't know, I've done it for a couple of years now, but every Wednesday, what I do is I collect a couple of variables. Let me minimize this so I can show you the tabs at the bottom. So the exercises that we do are dips, push-ups, L-seats, pull-ups, mushroom circles, and handstand holds for time. And I may as well, after this, I'll show you the strength and conditioning that we do. And I'll show you why I choose to do dips, push-ups, L-seats, pull-ups, mushroom circles, and handstand holds. Everybody knows how to do dips. I don't think I need to spot dips. Everybody knows how to do push-ups. And now that I just taught you guys how to do the curl-up test, you should be able to do push-ups the same for every kid. It doesn't matter whether or not this kid here, this kid Omar can, or Landon can do 70 push-ups, right? Because you see right here, he starts with 54, then 70, then 45, 46, 36, 42, right? What is this 70 all about? Most likely this 70 is an erroneous number, and it's probably because the technique of the push-up wasn't done very well. Where I also noticed this kid, Timmy, he's 8, he did 10, and then he did 46. So this number here is questionable. Same thing, Jacob, 30, then 10, then 11, then 30. So you see the numbers, and then 7. So what I can do with these numbers is I can tell certain things. First of all, 10 and 15, he didn't improve. 30 and 7, he didn't improve. 36 to 36, still no improvement. Sam, 52 to 31, but 52 here and 52 here, not too much improvement. Leo John, 20 to 42, improvement. But these guys here, they're all under the age of 11, right? Omar here is 12, 13 years old. And Yusuf is old enough that I don't have him do all these push-ups. We do all other stuff. But let's say we're going to do kettlebell stuff, squats, bench pressing, all of those things. Well, I believe that if I do those strength and conditionings, I'm going to improve their shoulder stability, but I'm also going to improve their hip and knee strength so that they can stick and they don't have bad knees and stuff on landings. So we do a lot of kettlebell stuff. I'll show you the exercises that we do after this. But if the kettlebell exercises, if those and strength and conditioning and using weights, if those don't carry over to functional gymnastics exercises, then that strength and conditioning is not useful. So for my younger guys, for these guys who are all about 10 years old or younger, I have them do dips. They do push-ups. I don't have to spot this. I don't have to spot this. And these are unweighted. So if I'm doing all my strength and conditioning and curls and bench presses and squat with press and single arm rows, they should all have some type of functional carryover to gymnastics. So although we don't work dips and we don't work push-ups, we don't work L seats, if these things don't improve because of the strength and conditioning that we're doing, then I would say that either the kids are too young and they don't have enough testosterone in their body, or their technique isn't appropriate, or the way that we're assessing these things is incorrect. But if my strength and conditioning is working, they should get better at dips, push-ups. They should be able to hold an L seat. They should be able to do more pull-ups. And then mushroom circles and handstand holds. These are things like they do for pommel horse, and they have to hold a handstand. So if I do all of this strength and conditioning, but their handstand holds don't improve, then what am I doing this strength and conditioning for, right? If the functional parts of gymnastics don't improve. So I collect all this data to see whether or not the strength and conditioning is working. But let's show you these things here. So this is the weight. So I've taken body weight from December 2nd to April every Wednesday. And you would expect that these kids would increase their body weight, right? Because they're growing. Two things, they're growing, but they're also doing strength and conditioning. So you'll see Timmy is 8 years old and he went from 60.4, and you'll see that it increases 62.3, 63.7, 64.3, 64.7, 63.8. And now here, last week, he wasn't in the gym. But you can see in about, 4 months, he's put on about 4 pounds. That's pretty normal. He's a young kid who's growing. This kid, Jacob, went from 73.4 to 76.3 pounds. But you'll notice here, he went 73.4, 73.5, 74.2, 73.4, 74.5, 73.4. So between December and February, 2 months, he didn't put on anything. And then you'll notice here, he went from 73.4. A month later, now he's 76.7. So he put on 3 pounds in this month time here. And he was telling me he's exhausted, tired. He looks gaunt. So I take a look at his, talk to him about nutrition, and I realize that he doesn't like to eat anything, right? That's what we talked about here. So I told him to eat a lot of chicken and eat a lot of rice. In fact, what I did is I took that exchange document that I showed you, and I had him circle any food or fruit or brain or bread that he would possibly eat. And I had his mom go buy those things that he said that he'd eat. You see, he didn't put on any weight, nothing. And then after getting the food, he put on 3 pounds within a month, and he's been able to keep that. So this was a nutrition manipulation right here, and you see that it worked. So he's put on 3 pounds as well. This kid's put on 3.4 pounds. This kid's put on about 3, same the same thing. This kid 68.9, 70.5. So now the question is this strength or is this weight increase right here? Is that due to our just natural growth of the human body, the growth of the body, or the development of the muscle? But you see, this one's about 69 pounds, and this kid only put on about 1 pound. Thin, he's got super energy. He should probably be about 3,000, 4,000 calories, but he's only probably at about 2,000 calories. This kid here, all right, started at 64.9. Now he's at 67.9. So another 3 pounds. So this kid put on 3 pounds. This kid put on 3 pounds. This kid put on 3 pounds. So although everybody's totally different, what you'll see is that physiologically, everybody kind of functions similarly. So everybody has different hair color, different height, different size, different weight. But the physiology for one person to the next is relatively similar. So that's kind of cool. Leo John is a vegan, and his mom is super protective. So he doesn't do our body weight and our stuff like that, but he's vegan, and you'll notice that he did drop a little bit of weight, especially during the middle of the season. This is the beginning of the season here, and this is as the season is going. He got a little bit burnt out. He stopped doing the FGL, which is Fantasy Gymnastics League, which is the company I made. He stopped submitting videos. He started to drop a little bit of weight, and I noticed that he had a little bit of like chapped lips, or he has eczema. To me, I think that this is a nutrition problem. All right, Landon, 94.2, and he put on 98 pounds. So he's a little bit older. He's like 12 years old. But again, he put on about 3 pounds, 3 or 4 pounds, which is the same as what these guys are doing. Omar, 85 to 89, another 4 pounds. Sebastian, he's 105, and now he's 118. So he put on 13 pounds this season. Yusuf is 17 years old, and he didn't put on any weight, but that's because in December, we stopped hypertrophy training, and I want him to do muscle maintenance. And you'll notice that he went from 158.5 to 157.7. So he actually lost a little bit of weight. But that's kind of good, because less weight in gymnastics, especially towards the end of the season, means that they're going to have less weight that they have to hold up on rings. So their strength and the pounding on their body will be much less. So I want to know whether or not these things here are a result of increased muscle mass or increased mass in general. So I take a look at body composition. And you'll notice these guys are so young, though. You'll notice there's a lot of jumping around. Maybe I'll just ask the question. Let's say from here, you see Timmy, 9.8. These guys are the youngest guys. So Timmy's 9 or 8, and Leo John is 10. You'll see it says 9, 5, 7, 5, 5, 8, 5, 8, and then 5s and 6s. This is pretty consistent at 5 all the way across the board. Sam, 9.7, 14.4, 11.5, 8.2, 9.1. Really, really jumpy here. But then you'll notice Sebastian is 5.1, 5.6, relatively the same. Landon, 16.3, 16.8, relatively the same, but it jumps around. Now, maybe I can just ask somebody real quick. Why would those numbers jump around, Tatiana? Why do you think? Right, I'll show you. If you look at Yusuf's body composition, 20.7, 21.6, 21.4, 21.2, 21.1, 21, 19. So he's starting to lose fat, slowly but surely losing fat, right? But you'll notice 20.7 to 19.6, that's very little jump. Very little jump, 20.7 to 21.3, and that's in 4 months. But you see the jump for this 9.7 to 14.4 to 11.5 to 8.5 to 6.4. Why are these jumps happening where this is much more consistent? Why do you think, Tatiana?
I feel like diet would be a contributor to that, and that it's not consistent each week for that individual.
Okay, so it could be diet related. All right. What I think is that the scale that I use, the body composition scale, the mathematics in the scale is based on, the mathematics that we've been going through the class. It's based on a typical body type, but there is nothing typical about Sam's body type. He's like 4'1", but his muscle mass is through the roof. So I think that the calculations in the scale that actually determine or calculate his body composition is off. Timmy is 9, might be 8 years old, but the scale only goes down to 10 years old. So all of these results for Timmy, I just don't think are meaningful. All right, but I do know, say for instance, Scott, he's pretty consistent. His body composition is pretty consistent, 5, 5, 5, 5, 5, all the way. And if I look at his weight is relatively consistent, 68.9 to 70.5. But if he's put on say 2 pounds, and the body composition hasn't increased in terms of its fat percentage, then I would say that those 2 pounds are pretty much mostly just muscle mass put on, right? Yusuf put on 158 to, sorry, he put on 158 to 160.7, and his body comp is staying relatively the same. So his amount of muscle mass is staying. He's not increasing fat to decrease muscle mass. Sebastian went from 5% to 8%, but he didn't really work out too much. He's not really that concerned with gymnastics. And Omar went from about 13% to 14%. So Omar is staying relatively the same. This is a little bit of an anomaly here, but 13, 7, 14, 13, 13, 14, 13, 14. So Omar put on about 85.5 to 89.8, and his body composition didn't change. So I would say that a good 4 pounds here, minus the 17% for your bone weight, I would say about 4 times 17, I would say probably a good 3.5 pounds in this 4-month time is due to muscle mass. Right, and the last thing I would show you is this bone situation here, bone density. Yusuf is the older guy. His bone density is 8.3 units, and I don't even know what the units are for the scale, but you'll see 8.3 really consistent. You'll see Sebastian 7.8 across the board. You'll see Omar 7.1 in the beginning and 7.1 at the end. So the consistency of these bone values is there. Sam, 6.8, all across the board, 6.8. Scott, 7, 7, 7, 7, 7. All right, Leo John, 7.1, 6.8. All right, and now this guy here, let's say Jacob, 7.1, 7.1, 7.1. So I noticed, and the reason I started to collect this value here is there are some kids that get growth plate problems. There are some kids who have Osgood-Schlatter's disease. There are some kids who do not. All right. Which one of these kids has enough calcium in their diet? Which one of these kids plays outside a lot? And which one of these kids plays a lot of video games? Aubrey, what do you think? Which one goes outside the most?
Um, can like I don't know how you would tell.
All right, so this is the way I think. All right, bone mineral density. All right, that means that there's a lot of calcium, right? If it's more dense, then there's more calcium. and calcium is absorbed into the bone if there's enough in the bloodstream. And you're going to get enough calcium absorbed into the bone, A, if there's enough calcium in the bloodstream, but B, if there's enough vitamin D. And one of the ways to get vitamin D is to drink vitamin D fortified milk or to go outside and play a lot. So you take a look at these values. Who's got the highest bone mineral density? And then who do you think drinks milk, Aubrey?
Yusuf has the highest bone mineral density.
Yeah, so do you think he drinks milk?
Yeah, probably.
Yeah, the other day I asked him, I said, Yusuf, do you drink milk? He says, oh, yeah, I love it. Which one of these kids does not drink milk?
Sam,
Hates it. Asked him the other day, do you drink milk? Hates it. Which kid also does not drink milk?
Jacob.
Yeah, Jacob has nutrition issues. He hates eating in general. But Timmy does not drink milk. Doesn't like it. Juice instead. Let's just see body comp. He drinks juice instead. I mean, I can't really say anything about his body composition, right? He's too little. But he doesn't like milk. He's also a huge gamer. Video games all day, every day. So Sam, he doesn't play video games, but he doesn't drink milk. Leo John has a vegan diet and he doesn't drink milk at all. But Yusuf is always biking, outside, running, doesn't play video games, draws, all that stuff. And he says he loves milk. All right. So which one of these athletes do I think, if I just look at these kids here, right? I look at these guys here, they're all under the age of 10 years old. Which one do you think I'm concerned with in terms of growth plate problems? All right, now Sam is already 4'1". He's already tiny. It seems as though here he doesn't have the highest bone mineral density. What impact do you think that has on his growth plates? Right, I would think that he wants to drink a little bit of milk and play outside so he's got a little bit more calcium in his bones. Or if there are growth plate issues, who do you think is going to present with growth plate problems? Or let's say we do circles on mushroom and we do like, I don't know, every day I have the guys do 200 circles. Which one of these athletes is going to potentially have a growth plate problem in their wrists if I keep pounding on them without rest? Right? So I try to collect this data as some information to see if I can predict anything. Now, I'm not going to be able to predict much, especially because these kids are so abnormal body type that if I compare their numbers to gold standard numbers, I'll probably be misled a little bit. So I don't really tell them, oh my God, your body comp is wrong or is off or whatever. But what I do look at is trends. I look at trends in what I notice. If I notice things that are way off, then I can kind of intervene a little bit. Right. So here what I do is I look at this bone thing. If this goes down to 6.7, 6.6, 6.5, right, it's 6.8 the whole entire way. These are all super consistent. So now if I do notice some changes here, if this is 7 and all of a sudden it's 6.4, I would have something to be concerned about. Right? I would notice that there's a big drop. Maybe we got to address something. This also, see 8.3, 8.3, 8.3, 8.3, 8.3, 7.8 all the way across, 7.1, 7.1, 7.1, 7.2, 7.2, 7.2. How do I know that these values are correct? How do I know that these body composition values are somewhat reasonable? Well, I have like a concurrent with the time validity. This right here, the consistency of these numbers tells me that the scale is working consistently every day. So that these values and these values are most likely correct. All right, so these are the benchmarks that I judge. I usually look at heart rate, but I haven't done it this season too much at all, right? And the reason I look at heart rate is because, and especially resting heart rate, if I look at resting heart rate and there's an increase or a decrease in resting heart rate, to me, that's an indicator of overtraining, because remember, overtraining can negatively impact your parasympathetic or sympathetic nervous system. So if I notice big change in resting heart rate, then that might be an indicator that maybe we're training too much. But I didn't collect that data this year. Okay, I may as well, let's save it, why not? Let's take a look at one last thing. Let's take a look at the strength and conditioning workout that they actually do. Give me one season, one thing. Conflict dates, NGA strength testing. I think that this is it. No. I'll have to email it to myself. Give me 1 second. I'm just going to email myself this, and then I'll be able to pull it up, and I'll show you kind of the strength and conditioning stuff we do. All right, I just airdropped it. So we are talking about adolescent strength and conditioning. So why don't I just open up my strength and conditioning plan, and I'll kind of show you what we do with these guys. So what we do is I start with my hypertrophy phase in the off season. So my national championships are in about 3 weeks, and therefore for the rest of May, I want to do an off season. So it's mostly rest. I wouldn't mind doing a lot of Zoom workouts, but then as of June 1st, it's actually June 2nd this year, we start our hypertrophy phase. So we do 6-week blocks. I showed you the 6-week blocks at a little while ago. And what we do is, let me explain what this looks like. All right. So this is my Monday, Tuesday, Wednesday. These are my plans. This is what I want to do. All right. This is what we're focusing on. Monday is lower body, and Tuesday is upper body. Wednesday is off, and we do our strength testing. Thursday, lower body, Friday, upper body, and then Saturday and Sunday, they're off. All right, my secondary focuses here on Monday are my scapular, my subscap stability. All right, so this is what I'm focusing on here, subscap stability on my secondary goals. So what we do is we do 6 weeks, and we do a light week, medium week, heavy week, and then light, medium, break the muscles down, and then train them for the next exercises and have them deload so that they can like increase protein synthesis. So everything is 6 week time blocks. So this is a mesocycle. All right, within that mesocycle, you might have a microcycle, which is a week-long cycle. So week 1, June 1st, these guys are going to do 3 sets of 15 Romanian deadlifts. All right, 3 sets of 15. Then what they're going to do is they're going to do these 3 things in a circuit. They're going to do them 3 sets of 15. But if I need to do it on either side, then I would do 7 on each side. So they'll do they'll do 15 goblet squats, elbows to your knee, holding on to the weight in front of you racked, elbows to the knee, goblet squats. I also have them make sure that they stand on the outsides of their feet with their toes splayed so that they have nice round arches. So they do goblet squat, Then they do a body weight jump, and then they do squat to stand with reach. Now, in gymnastics, they get bonus for landing, for sticking their landings. And on floor, there's 5 of them, and you have to land from each gym. So I'm trying to establish a good squat pattern and good Romanian deadlift pattern and try to get them to use their bum instead of their lower back or their waist to do landings. So we focus on good squat, specificity of training. So we'll do goblet squat, body weight jump, squat to stand with reach. The goblet squat, this is weighted. This is with body weight, and then this is a rest. All right, so I'm trying to use a weighted exercise, a body weight exercise, and then a breathing exercise. A weighted exercise, a non-weighted exercise, a breathing exercise. And then we have kind of similar things. So they're going to do goblet squat, body weight jump, squat to stand with reach 3 times around, 15 each. And then when they're done with that, they're going to do step ups, like you have a big box, and they're going to step up to the box. They're going to do lateral step down and lateral sliders. I'm not going to explain necessarily what they are, but this is all about hip and knee strength, and also with the step ups running technique, because they got to run and vault. 3 sets of 7 each. Then for 3 sets, they would go 20 seconds on and 20 seconds off. They would do jam ball slams. So they lift the ball up and the ball doesn't bounce. They smash it into the ground. They got to pick the ball up, lift it up and smash it, pick the ball up, lift it up and smash it. And then front raises like a push up that you lift one hand and the other hand, working on their upper back, posterior shoulder stability. And then same thing, core strength. Instead of sit-ups, we do a lot of like core strength by doing functional activities. And hopefully if they do these things here, right, if they do these things here, their push-ups will improve, their sit-ups will improve, their functional gymnastics strength will improve, but I don't do too much functional, like too much gymnastics strength training. I try to accomplish this gymnastics strength training using this stuff. So week 1, they would do 3 sets of 15. If you can do more than 15, what I want you to do is increase weight until you can only do 7. The next week is the same exercises. This is Monday, but I want you to do 3 sets of 12. So now the intensity increases. And again, the intensity increases. And now the muscles are really being broken down, harsh breakdown of muscle. Then week 5 is 4 sets of 15. As much weight as you can put on, break your muscles down, shock week. And then the next week is 4 sets of 12, reduce the intensity, learn how to do the exercises for the next hypertrophy phase, which would be here. But anyway, let me just go back to day 2. So this is day 1. This is Mondays. On Tuesdays, we do different. Tuesdays is an arm day. And just to kind of mix things up a bit, we don't do it based on sets. We do it based on time. So here, we're going to do 3 sets of 30, 3 sets of 30 burpees. 30 seconds of burpees, 30 seconds of rest, 3 times around. Get their heart rate up. So in the beginning, you have these like starter exercise, an RDL here, 3 sets of 15 RDLs. Then we have 3 sets of 30-second burpees. And then we do this circuit where they do 3 sets of 40 seconds on and 20 seconds off. And in that 40 seconds, I want them to get to 10 sets. So 10 reps. So they do floor presses. And we're spending between now and the end of May teaching them how to do these exercises, but also figuring out the weights that they need so that on week 1, on Tuesday, we're able to do this strength and conditioning work. So for the last month and a half, I've been teaching them the technique that I want them to use and establishing weights. Then we do, says TRX inverted row, but what we do is a renegade row, and then single arm half kneeling press, reverse flies, med ball chest press, pull-ups, bear crawl, and then underhand row. And then we'll go through that again. So they do floor press for 40 seconds, 20 seconds of rest and then inverted row, and then 20 seconds of rest and single arm half kneeling press. And then we go around and do this 3 times. And when we're done with 3 times, then we go and do our kettlebell armbar get-ups, kettlebell get-ups, Turkish get-ups, and arm bars. So shoulder stability, right? You take a look at this. This is floor press. This is pectoralis. This is subscap. This is pressing for shoulders. This is subscap. This is pectoralis. This is shoulders. So everything goes subscap, pec, subscap, shoulders. Pec, subscap, shoulders. Everything kind of pull, push, right? Pull, push, and press. Pull, push, and press. So everything trying to vary what we're doing in terms of muscles that are being, I guess, innervated or exercised. And then we have our rest on Wednesday, and then Thursday back to a leg day. Barbell squat to press, body weight lunge drop, same thing. A weighted exercise, a body weight exercise, and a resting exercise. A weighted exercise, a body weight exercise, and a resting exercise. And then we do like speed and agility training with ladders, just like they would do in football. And then one more core strength med ball overhead slams. And then on Friday, last thing, cliffhangers, this is an arm day, same thing, right? So, and then after that goes 6 weeks. And then weeks 7 to 12, I have very similar kind of layout, but all completely different exercises. And then we have our strength and power phase, same layout, completely different exercises. And then we have the strength and power phase that goes for however long it goes. And then after the strength and power phase, weeks 4, we have our muscle maintenance. We don't have to necessarily go through the whole thing. But what I try to provide to my athletes is indeed a strength and conditioning exercise or program that is designed to increase all of these, cardiovascular fitness. We do battle ropes. We do all sorts of stuff. But, these kids are young. Timmy's 9 years old, and I'm going to have him do all of this stuff. I'm going to have him do it with very light weight, but I'm going to see if I can go through this whole strength and conditioning program and teach Timmy how to lift effectively, and teach him the exercises so that when he gets to be closer to puberty and he's developing testosterone, he's able to do all of this strength and conditioning work. So what we're trying to do is I'm trying to increase the muscle mass of my athletes slowly but steadily. All right, eventually I want my athlete's body composition to be about what, 10 to 20. I'm not really trying to reduce body composition. I'm only using the variables that I collect as an indicator of relative body composition. So I'm not comparing one athlete to another. I'm just trying to see whether or not there are trends in that athlete's numbers that I can start to maybe intervene if things go differently. So as you increase your age, you're also going to increase your muscle mass. 25% of the body weight at birth is muscle mass. And then eventually, as you get older, there's going to be increases to about 40 to 45% of body weight in young men. And that muscle mass peak is going to grow or increase until about 16 to 20 years for the females and 18 to 25 years for the males. The increased muscle mass is, again, mostly because of increased hypertrophy, which is the laying down of more actin and myosin around the already established muscle fiber. And muscle elongation happens not because you're actually stretching the muscle like a piece of saltwater taffy, but because there's an increase in the number of sarcomeres laid from one side of the muscle to the other, which can also help increase muscle length. But whether or not all of this stuff happens is, I think, probably a hormone driven cycle. So if my athletes are not old enough and they don't have hormones that are coursing through their body, or if they don't have the right diet, or if I'm not doing the correct number of reps or sets, or I'm exercising 5 or 6 days a week and not giving any rest, well, then it's most likely that there's going to be some difficulty in me establishing the growth and development of their muscles. All right. So the amount of fat that an individual has is different than the amount of growth in muscle. In muscle, there's an end to the muscle growth, especially if I don't continue to work on that muscle, such that at about 20 years of age, our muscles are done in terms of natural muscle mass growth. But fat is different. Fat can grow forever. There's no limit to the amount of fat that an individual can store on their body. And that's going to be dependent upon their diet, the amount of sugar, the amount of exercise, and also some hereditary. Now, the amount of fat in your body can be adjusted via these two lifestyle um, modifications, but realize that an individual's diet is a behavior that, albeit it is changeable, it's a behavior. And that behavior we talked about with Robert Lustig. Remember, those behaviors could be caused by an external factor such as sugar. Same thing with these exercise habits. These could be manipulated and changed, of course, through behavior modification, but they can also be influenced by things like advertisement and sugar and other products that are in our foods. For the most part, we're going to have about 15 to 25% body fat. We do not want to eliminate body fat. We want to manage it. Body fat is important. All right. It's important for the absorption of certain vitamins and other responses in the human body, but fat is a good insulator. And it's also the structural component of cell walls. So we don't want to get rid of fat. And some individuals or individuals who do sport are going to want more fat than others, right? Like a sumo wrestler or a down lineman might want to have more body fat than another. Same thing with a swimmer. And there are other sports that would require less body fat, like a gymnast. The fatter or the more body fat a gymnast has, the more force that they have to kind of carry and absorb through their cartilage and stuff. So it could be the case that certain sports want to have a higher percent body fat than others. And our goal is not to eliminate body fat. All right. Our goal is to manage it and understand it. In regards to fat mass, you'll notice that the fat-free mass increases at a steady rate for both males and females until about 14 years of age. And then the fat-free mass for males starts to really plateau at about 18 years of age, but a little bit earlier for the girls. And there are differences in percent body fat associated with males versus females, but a big difference in the percent of body fat for females. You'll notice that females have a higher percent body fat. A lot of that is fat storage for reproductive purposes. All right, so females should not necessarily be trying to mimic their male counterparts in terms of percent body fat. And you'll notice at the age of about 12 years old, there is a reduction in percent body fat for the males, but there's an increase in percent body fat for females. Okay, so a lot of the development in terms of performance and sport and running and gymnastics has to do with neurological development in childhood. Remember, your neurons are covered by that myelin sheath, and that myelin sheath helps establish appropriate synchronization and timing of your action potentials down your motor neurons and innervating your muscles. So at very young ages, a lot of the growth and development, or a lot of the improvement in balance, agility, and coordination is because of neurological development and changes, as opposed to muscle strength changes, especially in childhood. Now the chapter starts to talk about acute changes to exercise for young children. What happens to their strength when they do exercise? What happens to their cardiovascular fitness and their respiratory functioning? What happens to their aerobic capacity? The easiest way for me to explain it is that now, according to the book and according to the work that I've done with my athletes, they are able to increase strength using strength and conditioning or weights or kettlebells or whatever. They are able to participate in this strength and conditioning um, uh, process, and it seems to work. All right. Omar put 25 pounds on last year. Omar was 11 years old. He put on 25 pounds last year. So they are able to get stronger for sure. And when I took when I take a look at their data and I take a look at the strength and conditioning that we're doing, all right, and then I compare the strength and conditioning that we're doing with, say, for instance, the functional exercises that I measure, it seems as though the strength and conditioning that we do carries over to handstands and functional gymnastics exercises. So the strength that we do with the kettlebells and the barbells and dumbbells, it seems to carry over to functional gymnastics strength. So I think that the strength and conditioning is working. Now, the number one thing about this strength and conditioning thing is, as long as it's supervised. Supervised. 85% of all of the injuries that occur with young kids doing strength and conditioning with kettlebells is because they're unsupervised. And I tell the kids that a kettlebell or a weight or whatever, they're tools. And my dad would always tell me, put your tools away. So I try to make it so that the workout environment, when we do strength and conditioning at the end of the day, is there's no talking, there's no fooling around. All of the weights have to be tucked against the wall so you can't trip against the weights. And anytime I can use things like um, ankle weights or body weight or sandbags or weight vests, I try to use it because it's more likely the case that if I drop a 45-pound plate on my foot, that my foot will become injured, as opposed to if I drop a 45-pound sandbag on my foot. So as long as your strength and conditioning bouts of exercise are supervised, it seems as though that the athletes are able to increase strength. Now, if the athletes do not grow that little teeny like fake adolescent mustache thing, then I don't expect that their strength and conditioning is going to be as effective as if they were 13, 14 years old. Last year, I did do the strength and conditioning with an 11-year-old, and it seemed to work great. And this is the first year that I'm going to work with Timmy, who's 9, but I'm not going to let Timmy use anything heavier than 3 or 5 pound weights. Hopefully this year we'll just be able to teach him the exercises, and then next year and the year after we don't have to go through that same process. So as long as things are supervised, it seems as though that strength and conditioning and with typical weights, but also body weight training seems to be very helpful. In regards to cardiovascular and respiratory functioning, all right, be aware that a child's heart is much smaller than an adult heart. And if cardiac output is equal to heart rate times stroke volume, all right, there's no way that an adolescent heart can have as great a stroke volume because it's just smaller. And if that's the case, they're going to have to make up their cardiac output demands in regards to heart rate. So for the most part, a child's heart is going to have to beat more times to deliver the same amount of oxygen as an adult would. Now, the drawback or the difference between adults and children is, well, not the difference, but one of them is that there is less peripheral perfusion, which means there is less, like, for instance, I don't know, like an adult is probably like at some point, maybe has cardiovascular disease, or maybe they smoked and they have less ability to diffuse oxygen to carbon dioxide in their blood vessels. A child is most likely going to have less issues with perfusion or with the diffusion of oxygen and carbon dioxide across their membranes, because their tissues are pretty much, brand new. So although they might have to have a higher heart rate, their perfusion or their atrial ventricular difference between pressure of oxygen and carbon dioxide is higher, so they'll be able to get a little bit more oxygen in their system. But a child's heart is much smaller than an adult's heart, and therefore we cannot treat children as just smaller forms of adults. All right, we need to be cognizant of the fact that their hearts are different and that they will require different physiology to accomplish the same thing that a regular adult would be doing. All right, but you can use exercise to improve strength and cardiovascular fitness, and also the way that an athlete or a young athlete is going to metabolize food or metabolize their micronutrients. So I can improve their aerobic capacity. I do a lot of fast glycolysis training, not slow glycolysis, because my athletes don't do slow glycolysis, but they will do things like battle ropes, burpees. They'll do things like trying to do about a minute and a half, 1.5 minutes of complete and total savage workout with battle ropes or burpees or box jumps or anything. And then they'll do about 5 minutes of rest. So about a 1 to 4 work to rest ratio. And they'll do like fast glycolysis. So 1.5 minutes of burpees and then 5 minutes of rest. And then instead of working their slow glycolysis, which would be somebody who wants to do endurance training, I'm working on their fast glycolysis. So I do want to make sure that I'm thinking about what metabolic process would be most appropriate for my athletes, and then do my specificity of training to target the slow or fast glycolysis. With fast glycolysis, I have my athletes do a lot of, like I said, battle rope training. If I wanted my athletes to do slow aerobic training, I would do that during the off season, during the summer. And the only reason I would have a gymnast do aerobic capacity training at slow glycolysis is to improve their lung size and improve their lung volume, and also increase their heart strength. And if that's the case, they would be able to give the body more oxygen in this 5 minutes of rest. So I'm only doing slow glycolysis during the summer to better, I guess, address their need for fast glycolysis. Then after the summer is over, I would not have my athletes doing slow glycolysis any longer, because any slow glycolysis stuff that they do is potentially going to reduce their fat-free mass. And if they have a reduced fat-free mass, then they're going to have a reduced strength. And because my athletes are involved in a strength and power sport, I do not want them losing fat-free mass because of their summer slow aerobic capacity training. So they'll do summer training, they'll do a little bit of aerobic capacity. If they want to run a mile or two, they can. But then during the end of the summer, we switch to all battle ropes, 1.5 minute fast glycolysis training. Now it says running economy here, but I mean, this could be gymnastics economy, lifting economy, any kind of, sport performance economy. And economy means really like technique. Economy is, if something is economical, it means it costs a little bit. It doesn't cost a lot, but it results in a lot of a like, I guess, a result, right? The result is great, but the cost is very little. So as an individual doing exercise, as a young athlete, doing exercise improves, their acute exercise performance is going to increase, but not because of muscle mass increases. Most likely, those athletes are going to increase their performance because of their technique changes. An increased technique or better technique means that the economy or the amount of oxygen that I'm going to spend to do that bout of activity is going to be less than normal because my technique is improving. All right, so a lot of these changes in strength due to for adolescent um, athletes is due to cardiovascular or is due to neurological functioning, and those and you'll also have acute changes to their cardiovascular fitness and their ability to break down those macronutrients, those carbohydrate, protein, and fat as they continue to practice and such. All right, so. All right, so where are we here? So in regards to strength, all right, strength increases peak at about 20 years for men and women, especially if I'm not continuing to work strength through resistance training. All right. In regards to typical increases in strength, this is the leg strength of typical male, and that you'll notice that there's an increase in strength here. There's an increase in the rate of strength. Right here, you'll notice that there's like an inflection point here, sort of. Right at about 12 years, there's an increase, and then at about 16 to 18 years old, there's a reduction in the relative strength as an individual gets older. In regards to resting and submax blood pressure, the blood pressure is typically lower in adults compared to younger athletes because the younger athletes have smaller hearts. And then there's lower peripheral resistance. There's lower resistance, or it's easier for oxygen to switch with carbon dioxide in the periphery, in the blood vessels of the arms and legs and the muscles of the arms and legs. There's less arms and leg blood vessel difficulty in terms of the diffusion of carbon dioxide and oxygen for younger athletes because their blood vessels are healthier. So although they do have smaller hearts, they do have better perfusion. So as your athlete is doing your fast glycolysis and battle rope training, right? It might say that submaximal exercise, right? It could be that these athletes should be working at 220 minus your age. And that is my maximum heart rate. 220 minus your age. I'm 44 years old. So let's go. My max heart rate should be about 176. So for Timmy, who's 9 years old, his maximum heart rate should be at about 211, right? 211. So if Timmy is doing battle ropes and his heart rate gets to about 211, that would be an indicator of stopping the bout of exercise because it's not supposed to go higher than 220 minus his age. For me, my max exercise heart rate is 176. So if I'm doing treadmill work later on today and I'm on the bike and I notice that my heart rate goes to 176, that's an indicator that maybe I should stop that bout of exercise. For Timmy, it's 211. But what I want to do is I want to understand that Timmy's got a lower stroke volume. Because of that, he's going to have a higher maximum heart rate. So when I have my guys do their battle ropes, instead of trying to get their heart rate to 220 minus their age, for Timmy it would be 211. I'm going to overestimate their age and be a little bit safer for my younger athletes because they have a smaller heart. So I don't want to go to 220 minus their age. For my athletes in the gym, I estimate their age as 20 years old for all of them. So the maximum heart rate that I want any of my guys to get to is 200. And then if I want to make sure I'm working on their aerobic capacity, I can work at 85 to 90% of 200, but I'm not going to work 85 to 90% of 211. So I give my athletes this little 11 beats per minute buffer to just make sure that they're safe, because I have to understand that my athletes have a higher heart rate because of their smaller heart. Now, the atrioventricular difference is going to increase their submaximal stroke volume to help with the fact that they have a smaller heart. But for me, the adjustment that I make for my athletes because they're young to acute exercise is that I overestimate their maximum heart rate. I consider all of my athletes 20 years old, and then I would stop the bout of activity earlier than later because I want to make sure that my athletes' cardiovascular health is maintained. Okay, so let's go on to the next slide. So if you look at heart rate, beats per minute, all right, a boy is always going to have a higher heart rate, all right, doing the same bout of activity than an individual who is past adolescence. So young kids have higher heart rates. So the heart rate for young kids is not the same as heart rate for older individuals. Stroke volume for an older individual is much higher than stroke volume for a younger athlete doing the same activity. It's because the heart is smaller. So not only is the heart smaller, but the heart has to beat faster in order to accomplish the same stroke volume. And it doesn't seem as though the younger athlete is able to accomplish the same stroke volume. So to expect your young child to run the 10 miles right next to you is probably pushing that athlete's heart past where it should be. Same thing. I mean, you have a little dog. You have a little. My mom runs. She just got a little mini schnauzer, and she runs, with the mini schnauzer. But the mini schnauzer's heart is so small. Think about the amount of heartbeats that dog would have to, have to keep up with my mom. And you look at oxygen cardiac output, although the difference here in stroke volume is much higher here from the adult to the younger athlete. The heart rate is much higher for the boys than it is for the adult. The stroke volume is much lower, but you're still able to get a relatively close amount of cardiac output. But notice that the adolescent is still lower than the adult. So the take-home message is that the young adolescent athlete is not the same as an adult athlete. All right, there's a higher maximal heart rate in adults, higher maximal stroke volume. The stroke volume is lower in children than it is adults. So we have to just treat them differently. With acute exercise, I can improve lung function. I can increase the tidal volume, which means I can bring in more oxygen, which means that when my athletes are done with their fast glycolysis and all of their ATP is burned out, I'll be able to get oxygen back into the system to create ATP and get them ready for their bout of activity, or to get their hydrogen ions that are created because of the creation of lactic acid. I could get those neutralized better if I have better lung volume. So during the summer, I want my kids to run, but I only want them to run to increase lung volume and oxygen so that when they do their fast glycolysis, it's better. All right. And again, metabolic function increases with age because of increased muscle mass. And increased muscle mass makes it so that there's increased muscle cells and fibers to break down any excess glucose or fats or metabolic byproducts.